All right, I'm Jesse, and as you saw earlier in the keynote, I'm a Senior Principal Software Architect at Autodesk, and I'm currently working at the juncture of our security compliance teams and our developer enablement team. And when I'm not in front of my computer, I'm absolutely dependent on to be a continuously delivering parent.
Hey guys, my name is Manabu McCloskey. I'm a solutions architect for AWS. I work in open source team. I am focusing on infrastructure tooling. Outside work, I like to play video games, mostly like Dark Souls series.
All right, so first a quick agenda. We're going to look at ACDP, which is our Autodesk Cloud Deployment Platform, which we call CloudOS, and then go into some of our IaC pain points specifically, which drove some of the work that we're about to show you guys. And then we're going to look at the architecture of the solution that we came up with, and then Manabu is going to give a deep dive on how everything works. So the Autodesk Cloud Deployment Platform, or what we call CloudOS, is our current attempt at consolidating our continuous delivery primitives used to ship Autodesk software. About 4 years ago, we produced an internal strategy at Autodesk about how we should start doing modern delivery of our software to the cloud. Spinnaker was core to that strategy, as were the basic tenets of GitOps. And although GitOps is still a little bit of an experiment for us, still not truly commit to production, we've been using Spinnaker for about three and a half years now. And much of the early UX for this platform was informed by our previous homegrown CD cloud orchestration tool. And to ease our users' transition onto our Spinnaker-based solution, an abstraction layer was built to match that prior experience. Central to that abstraction is something that we call the ADF, our application definition file, which you also may have seen in the keynote that Cole gave with me earlier. It's essentially a declarative YAML manifest of infra and app artifacts to be deployed. That definition is piped through our translation layer, which Shore is the project that's critical to that, and translate those from these abstractions into Spinnaker pipelines and Terraform values files. And I want to stop here and make a brief plug for Shore, because if you would like to know more about it and how we're doing those translations and the wrangling that it does, some of my fellow Autodeskers are going to be doing that talk later today. You should check it out. So those IaC pain points that I was talking about, right? The imperative pipelines that we're producing are a combination of Spinnaker native stages and Terraform, and also ad hoc containers mixed in. The Terraform stages use Armory's Terraformer to invoke a curated set of Terraform modules, but because of the diversity that our product teams need to be able to do the products they're building, we must also allow for a bring your own Terraform path as well. And the unfortunate side effect of that is that it allows for a lot of diversity in the module design as well, which is an issue for our security and compliance teams. How can we know that the infrastructure and the modules that they're producing meet our regulatory requirements? How can we alleviate our developers from having to think about how to implement those controls into all of their modules, right? There's a developer enablement play there too. And our security and compliance teams want to help. They want to be partners. So they've even go so far as to produce a reference set of hardened modules for teams to use, like Cole also showed a little bit earlier. However, those hardened modules are not a requirement right now. It's not compulsory to use them, and adoption is still a little bit best effort. How can we empower this security team to take ownership over these concerns? And then finally, lazy reconciliation causes its own host of problems. Because we've tied our infrastructure lifecycle management to the delivery of our applications built on top of it, we end up with varying gaps of time between our Terraform runs. This not only causes drift to occur in these dynamic cloud environments, but also limits how quickly we can respond to mandated changes company-wide. Enter Crossplane, right? A Kubernetes operator-based control plane for APIs. Be they cloud provider APIs like AWS, Azure, or GCP, or your own internal APIs, Crossplane can map them to declarative CRDs that define your desired state. We don't have time to go into Crossplane in great detail, but just know that Crossplane has first-class support for major cloud providers, which gives us that infrastructure lifecycle management that we were looking for. Crossplane also models its code reuse around the idea of composition, which is similar to how Terraform modules Terraform submodules work. And using this, we can build compositions that teams can combine and extend to meet their needs, like you're seeing with this diagram. And because this is all done in the context of the Kube API, we can make use of Kate's RBAC and enforce that separation of concerns, right? You can see some of them under lock and key. This means that we can build a library of curated primitives and nurture an ecosystem of higher level abstractions like Autodesk compliant database that mask away a lot of the toilsome nuance that comes from working with high fidelity tooling. This is what developer enablement starts to look like. Finally, since it's designed as an operator, we can rely on the battle-hardened Kubernetes reconciliation loop to continuously make sure that our desired state is abided, and we get notified immediately. So considering the problems we were experiencing and the desire to continue to push our developer enablement bar upward, we decided on some fundamental design goals, right? The first was to truly move to fully GitOps-driven workflows. We wanted to tear off our imperative band-aids and lean into that forced multiplication that declarative workflows give us. And next, we wanted to enforce that separation of concerns between our product, platform, and security teams, enabling each of them to focus on their own domains and not color outside of the lines. And then finally, we wanted to explore a topology that allowed us for more secure actuation of these changes in product environments, limiting the blast radiuses. So in order to meet our goals, we developed a hub and spoke model of crossplane instances running on a network of Kubernetes clusters inside of our client app accounts. Here you'll see Spinnaker, it's a little small, sorry guys. Spinnaker's logo's there in the center, in that central Kubernetes cluster, which is the entry point into the system. It's running all the usual microservices, as well as Keel, which is monitoring our enterprise GitHub down there in the bottom left for managed delivery manifests. It's also running the Kate's plugin for managed delivery so that it can continuously deploy crossplane CRDs into those crossplane instances that are in the clusters around the outside. An important aspect of this design is that we can continue to use the same tooling to build and maintain that network of Kate's clusters that underpin it. As we onboard new client accounts, the crossplane in the central cluster can be used to build those Kate's clusters in the new accounts and install crossplane on those clusters, kind of like turtles all the way down. During this bootstrapping phase of the new client account, Spinnaker writes those crossplane CRDs representing the desired state of those new client clusters directly into the crossplane that's co-tenanted on it in that central cluster. See that little lollipop there in the middle. I want to point out that this crossplane instance will need AWS API permissions on these client accounts to allow it to build those new Kate's clusters, right? It's got to be able to reach out to Amazon and say, give me a new EKS cluster. And then it also needs Kate's API permissions on those new clusters to be able to install those subsequent crossplanes on them. However, once those new clusters are up and operational, right, those permissions can be reduced, just allowing the management of those resources, or revoked altogether, kind of severing the tie, removing that central pivot point. Spinnaker, however, in the middle there, will retain those permissions to be able to write objects out to those Kate's clusters so that Keel can continuously write manifests to them. This allows for managed delivery to continuously deliver the crossplane CRD artifacts from our client GitHub repos that represent our client apps to those client clusters in those client accounts. The client crossplane instances will then build and continuously reconcile the infrastructure required by our client apps. Remember that centralized Spinnaker does not need to have Clouddriver permissions to those AWS accounts anymore. It just needs Clouddriver Kate's credentials to be able to write to those Kate's API servers in those accounts around the edges. The crossplane instances in those client accounts are now the ones who communicate with the Amazon APIs on behalf of our Infra's Code platform. Again, the reduction of blast radius there. So now that we have a bit of a high-level understanding, I'm going to hand it over to Manabu to dig into the details. Manabu.
Thank you, Jesse. All right, so let's dig right into the workflow that we wanted to enable for this work. So first, you have the infrastructure repository on the right. So this defines all the infrastructure that's needed for the application. So you might have like, K8 cluster definition, IAM roles, EC2 instance configuration, any of that, right? And then in the middle, you have that's the hub cluster that Jesse was talking about. So it's the hub cluster that has Spinnaker and Crossplane installed. So the first order of business is for Spinnaker to be able to talk to the infrastructure repository, right? So the infrastructure repository manifest has to go into Spinnaker, and Spinnaker needs to be able to continuously reconcile the differences between what is actually defined in the repository and the actual state of the infrastructure. And then you get all that manifest and then submit that to the hub cluster Crossplane, and then Crossplane is going to do its magic and then create the infrastructure that is needed for client account to function. Then as a result of the reconciliation process, it's going to create a brand new K8 cluster with Crossplane installed. And then finally, you have an application repository that's has the code and artifacts and everything that's defined. You have to be able to sync that between Spinnaker and the application repository. And then finally, Spinnaker needs to be reconcile the differences between these right? So this application repository might contain some information about infrastructures as well. So in that case, you just submit that to Crossplane, and then Crossplane is going to create S3 buckets, EC2 instance, whatever, right? You name it. And then you can also deploy all these applications into the K8 cluster in itself as well. Okay, so this is a little complicated, right? There's got a lot of workflow going. So I am just going to simplify that into just 4 steps. So the first step, just create the cluster, right? You just ask that Crossplane in the hub cluster to create a brand new cluster. And then the Crossplane is going to reach out to the client account and then create the EKS cluster with Crossplane installed. And then Crossplane comes back to Spinnaker and just say, hey, this cluster is now ready. Here's the credentials, here's the name of the cluster, so that you can deploy it, whatever you want into this cluster. And then finally, Spinnaker is going to take the information that's stored in the client application repository and deploy that into the brand new account that was just created. Okay, so the first step is to be able to sync between the infrastructure repository and the Spinnaker itself, right? It's got to be some way of, syncing between these repositories. Like Jesse mentioned earlier, Keel is an optional microservice within Spinnaker that enables GitOps-driven workflows. As you can see on the left, Keel has its own specification for its manifest. So you have you're defining artifacts and you're defining environments and then telling Keel to deploy all these artifacts into these environments. So then Keel is going to continuously reconcile with Clouddriver to deploy all these resources into AWS. Typically, you deploy into like EC2 instances or ALB or anything like that, right? But for our case, we needed the K8 plugin. So there is a Kubernetes plugin for Keel that allows you to deploy into the Kubernetes clusters instead of using EC2 instances. Okay, so we now know how to connect to the infrastructure repository, and then deploy, and then Crossplane is going to provision, right? So that workflow would look something like this. You'd have a GitHub, or you have a Git repository that has a Keel manifest stored. In this case, we're just using customize. And then Keel's plugin is going to take that, and then finally, it's going to ask Crossplane to deploy all that information into the brand new AWS account. There is a problem though. At Autodesk, they don't really allow role chaining. Role chaining means you have a database role, and then you are trying to assume another role from that role. So typically, when Crossplane deploys its own infrastructure or deploy anything in there, you'd use pod role, right? So IaC, so it's pretty much a identity assigned to role, and then use that identity to assume a role, and then from that role you assume another role. That's usually how Crossplane do its own, when you're deploying things. That's how they do it. Problem is that Autodesk didn't allow it. So how can we solve this, right? So thanks to Jesse's effort, he actually implemented this in the provider AWS. Mostly, yes. Let's see. So in this new model, you have an EKS OIDC. So whenever you create an EKS cluster, you have a option to create an OIDC provider, right? And what is happening in here is that client account is trusting that principal as an OIDC, the OIDC within Crossplane's namespace database. And then finally, you have a Crossplane pod that has its own token that's injected by the EKS admission controller, and then use that token to assume a role into client's account. So this way, there's no role chaining to worry about. Okay, so with this, we will actually be able to create the cluster and then come back to Spinnaker and then say, hey, it's ready, right? But there's a problem. How can we deploy to the brand new account? Coming back, there's really no information that's given to you, right? Like we need the information, like what server are we going to deploy to? What credentials are we going to use to deploy to, right? All that information is still not there. So how do we do this? Thankfully, the people from Crossplane thought of all this, right? So Crossplane has this concept called connection details. Connection details allows you to describe certain details about these managed resources. So managed resources could be like S3 bucket, DynamoDB table, EC instance, anything like that, right? So what these connection details hold is just information about these managed resources. So when you're talking about S3 bucket, it could be like name of the bucket, which region it's in, secrets or the encryption settings, anything like that. But in case of an EKS cluster, you are actually storing the kubeconfig file. So most of you probably know, kubeconfig is used to connect to these clusters, right? And so these kubeconfig files are available as a secret within Crossplane's namespace. So that's good, right? We can somehow use this. If we can connect the Spinnaker to Crossplane, then we can probably do it. So to solve this, we created a sidecar that runs along with Clouddriver. And what this sidecar is going to do is just go into the Crossplane's namespace and then list all the secrets that's contained within the Crossplane's namespace, and then see if these are kubeconfig files. And then if you find kubeconfig file, it's just going to write them to a YAML file on its own file system, and then have the Clouddriver read that YAML file. As you know, the containers share their file system, right, within the pod. And this Clouddriver has its own plugin. It's the external account plugin. I think this was developed by Armory people. What this plugin is going to do is just going to read that file, the YAML file, and then read and add these accounts into Spinnaker's memory. And then, if you remove a account from the YAML file, it's also going to be removed from the Spinnaker's account as well. One thing to note is that these secrets that's maintained by Crossplane, they actually refresh. So these, the tokens included in kubeconfig file, they expire, by 60 minutes or so, I think. So every time it expires and then gets refreshed, it's actually read by the sidecar as well, and then it's written to the YAML file, so that Spinnaker has the latest and valid token to use, and every time it needs to deploy something. Okay, so what that means is that it actually now allows you to use the Spinnaker's pipelines, right? So, on the left, we have a Spinnaker pipeline, just example one just defined, and then it's just going to do Orca, and then Orca just go do its own thing, and then finally just deploy it to Clouddriver. And when you're trying to do Clouddriver, you know which account you are supposed to use, just because we just made them available from the Crossplane's namespace. Okay, but there's a problem, right? Like we wanted to do GitOps, right? We don't want, Spinnaker's Imperator pipeline, it's good, right? It's great, it works. But we wanted to do a GitOps-driven workflow. So to do that, we had to leverage Keel. Keel's Kubernetes plugin, under the hood, it actually uses Flux. For those of you who do not know what Flux is a toolkit just allows you to have the enable GitOps workflow within Kubernetes cluster. So it's just going to reach out to the GitOps Git repository, fetch all the information that's necessary, and then finally apply that to the brand new Kubernetes account. But there's another problem again, right? Flux and Spinnaker, they don't really talk to each other. They don't really know how to talk to each other and just, exchange information about these accounts. So Flux, sure, it knows about Git repository, that doesn't know how to connect to the client cluster, right? It was just created. It doesn't know anything about the Crossplane's secrets model or Spinnaker's account model. So to solve this, we just expanded that sidecar to just read from the secrets in the Crossplane namespace, write it within its own file system, and write that into the Flux namespace as well. That way, Flux knows what kubeconfig to use, and use that kubeconfig to finally deploy all the infrastructure and application that's needed for the client account. All right, so the GitOps driven workflow will now look something like this. You have a customize that's defined on the left. It's defining the Git repository as well as a where within that repository you are supposed to use to create this customized overlay. So the first order of business is for Clouddriver to publish the kubeconfig file as a Flux secret. So Flux has its own a way of handling this kubeconfig file, so it's formatted in that way so that Flux understands how to use these files. Okay, and then so this manifest gets submitted to Keel, and Keel is going to do its own thing, and then finally ask Flux to deploy using kubeconfig 1, right? And then Flux is just going to reach out to the secrets within its own file, get the kubeconfig file, just read it, and okay, now I know where I'm supposed to be deploying, and then finally it's going to be able to deploy into the client's AWS account. So with all that in place, we now have this nice and easy to read model, right? So you have an infrastructure repository that defines all the infrastructure that's needed for the client account, and then it's just going to ask Crossplane to deploy it, and then finally the Crossplane just comes back and then say, hey, the cluster is ready. Here is a the secrets that you're supposed to use, and then Spinnaker is going to use that secrets and then deploy to the application into the brand new account that was just created. And then you can use imperative pipelines, or you can use the declarative way of doing it by Keel. Okay, so that's it I have for you. If you have any questions, please let us know. Yeah?
Do you have a microphone for questions? I don't have a microphone. No, they're going to get you one.
Hi, I guess I'm curious of the details about how number 3 works, how the feedback gets back to Spinnaker that the cluster has been provisioned.
Okay, yeah, I'm going to let you take it, Manabu, but I want to just repeat the question. So you're interested in how Spinnaker becomes informed that the new EKS cluster is ready and how it can speak to it?
Well, really just the readiness part. I think he covered how you speak to it. But it seems like there's an opportunity to like do number 4 before number 2.
Okay, yeah. So there's a timing question. Okay.
Right.
Yeah, so I can explain it a little bit. So it really depends upon like the workflow around this tool, right? Like at Autodesk, we still have kind of like an onboarding of clients to our system. It's not completely self-service yet. However, if it was self-service, there would be some sort of out-of-band notification that would say like, look, your tenant has been produced. You can now start writing your delivery manifests in this repo, and that repo might be provisioned for them as well. I can also imagine a situation where someone comes to us with a manifest, a declarative manifest in Keel's world that they want to deploy. However, they're still going to need to kind of onboard somehow. Like it's not the case that they can just say, hey, I have this repo, just deploy for me. They still need to have an account and VPC that's been provisioned, and all of that right now actually is kind of done out of band process at Autodesk. Does that sound familiar? Like, does that make it make sense?
Kind of. Yeah, I think what you're saying is that 3 is a manual process, that it's not automated.
Well, so let me. I don't want to ambiguate here. 3 happens automatically by virtue of the secret and the kube config getting written back to Spinnaker, and the dynamic accounts plugin then sees it and creates a new account, a net new Kate's account inside of Spinnaker. Only then can Spinnaker actually target that account. However, if someone was to create a client account delivery manifest and try to target it before that was written back, Spinnaker would just say, I don't know which account you're trying to use. I can't write that.
Okay, thanks.
Yep.
So looks like in the architecture that you eventually settled in, you have the Flux operator that is in the same cluster with your Spinnaker doing the deployments to the client clusters, right? Alternatively, you could have Flux deployed also to the client clusters and get Keel to just throw vanilla customized resources or whatever to that client cluster and have the individual Flux instances in the client cluster take charge, right? Any particular reason you chose one over the other?
Yeah, sorry, I hate to take all of them, but I'm going to be really quick about this. So that has a lot to do with Autodesk's security posture, right? They don't want to necessarily give all these accounts, all of these client clusters, access to be able to actuate all their changes all the time by themselves entirely, right? And so we are able to centralize that pipeline of the delivery of this application manifest, ultimately the declarative YAML that's been boiled down through our CD system, and it's like a centralized choke point, right? Like we can say this is not allowed, don't do that. But you're right, Flux could be distributed and then just rely upon the localized credentials on those Kate's clusters to be able to talk to the Amazon APIs for you, right? Okay, all right. Thanks, everybody.